Hi, this is the AQA Foundation Mathematics paper for GCSE, and it's a paper one, which means that you can't use a calculator. This is for June 2021. We get an hour and a half to do it, so let's see how we do. Question 1 is asking us to multiply 0.02 times 100. Remember, when you multiply by 10 or 100 or multiples of 10, the number will get bigger. In this case, there are two zeros, so this will move in this direction 2. The decimal point will move 2 places, so we'll end up with a 2 coming out. The next one is a simplifying. So they said simplify, and what we need to do is collect all the like terms. They're all x's, but you notice some of them are adding and some of them are subtracting. So we have x plus x plus x is going to be 3x. Take away 1 leaves us with 2. And then when we add another one, leaves us with 3. So we're going to get 3x. Or you could say 1, 2, 3, 4, because those are 4 pluses, and then take away 1 is 3. You get to the last question on that page, and it says we have 260 millimeters, and we're changing it to centimeters. Basically, you have 10 millimeters, make 1 centimeter. So in other words, we're going to have to divide by 10 to change it into centimeters. Divide by 10 means the decimal point will move in this direction, which means we'll end up with 26 centimeters. Question 4. Now question 4 looks like it's talking about shapes, so you need to remind yourself what the shapes look like. Rhombus, parallelogram, kite, trapezium. And they're saying which of these shapes can, don't have to, but they could have all the lengths being different. Now that cannot happen for the parallelogram, because parallelogram always has two that are parallel to each other, and the other two sides are parallel to each other. And so for that to happen, two of the sides have to be the same, and the opposite two sides have to be the same. So that can't be the case. A kite equally will have two sides which are short, and then two sides which are long. So these two sides have to be the same, and these two sides have to be the same. So again, they can't all be different. And a rhombus is a combination of both of those, where you have like a parallelogram and they're combined, so those are opposite each other, those are opposite each other. So it's a bit like a square that's been squashed. So the only option we'll have left is the trapezium, and a trapezium can have the sides all different, so top and bottom different there. If you want to, we could kind of make that go there. So this side is shorter and that side is longer, and you can see that all the sides are of different lengths. They don't have to be, but they could be, hence the trapezium is the answer for this one. Question 5 is a calculation one, and they're just testing that you remember what happens when you multiply a negative times positive. In this case, negative times positive is going to give us a negative, and 8 times a 5 will give us 40. So that comes out as a negative 40. We're now on to question 6. And question 6 is another calculation question. You're not allowed a calculator, so we're just going to have to see what happens. Luke buys 4 apples and 5 bananas. The total cost is £3.70. Each apple costs 35p. Work out the cost in pence of each banana. So what we're going to do is we're going to work out how much that costs when we bought 4 of them. So basically we have 35p times 4. Now obviously you could add, you could do 35 plus 35 is 70, and then again doubling that to get £1.40, or you could just multiply it like I'm going to do. 4 times 5 is 20, carry 2. I'm going to write it somewhere. And 3 times 4 is 12, plus another 2 is 14. So that's 140 pence. Okay, because remember, that was in p there, so that one's in pence there. Now, I could change this into pounds, but I won't, because the final answer they want is in pence. So in that case, I'm going to leave that one in pence. And what I'm going to do is I'm going to change the £3.70 into pence. To do that, you multiply by 100. So that will give me 370p. Now the reason I want to do that is I want to see how much of that was for bananas. So we're going to say £3.70 was the total cost, minus the cost for the apples. 0 take away 0 is 0, 7 take away 4 is 3, 3 take away 1 is 2. So we have 230 pence, which is going to be split between the 5 bananas. So now it's a division. So we do a division, and we say we have 230, and we're going to split it into 5. So 5s into 2 don't go, but 5s into 23 does, because you have 4 lots of 5 is 20. So I can say there's 4 lots of 5, 20. What's the remainder? Well, the remainder is 3, because basically 20 take away 23, take away 20. So the remainder is 3. So now I have 30. How many 5s in 30? Well, 6. So that's how many pence it costs for one banana. So down here in the answers, we can write that down. Oops, make a mistake, so let me cross it off. I meant to write 46 pence. Okay. Now, if you don't like division, you could try other methods. 4 marks, because basically you're working in pence, you have to work out how much for the apples, subtract. And if you don't manage this step, you probably still get something like 3 marks if you show your workings. Question 7 is a pictogram. Now, most people like pictograms, so let's see what they tell us. We're talking about Rashid counting the number of pieces of homework he's done in 3 subjects, maths, English and geography. And they have a key, and the key tells us that this represents 4 pieces of work. Down here we have that Rashid has done 5 pieces for geography homework, showed us in the pictogram. So in other words, we're going to need a full circle, split into 4, to show 4 of those. And then I'm going to need another quarter of a circle to show. Now, obviously, you could draw any part of the circle. I've chosen to do the top left, but you could have done bottom right, etc. So that shows 5 pieces, worth 1 mark. Then we come down here. It says Rashid spends 30 minutes on each piece of homework. Work out the total time it takes him. He spends on the homework for these 3 subjects. Give your answer in hours per minute. And if you notice down here to remind us, it's in hours and minutes. Now, there's so many different ways of doing this. You could add all these together and then multiply it by 30 and then change it into hours and minutes. But I'm going to do it slightly different because I noticed that each piece of homework is half an hour. So in other words, that is half an hour, that is half an hour. And I know that 2 lots of half an hour make 60, 30 plus 30 is 60, and that's 1 hour. So in other words, that bit there, I'm going to use a different colour. That bit there is 1 hour. Yeah, 2 of them is 1 hour. So I'm going to get 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 hours, and 1 of them left over, and that 1 of them is 30 minutes. So just by counting it that way, I didn't have to do any calculations, and I end up with 19 hours and 30 minutes, just by spotting that 2 of them make an hour. So I could go just count up how many hours I have, and then I had 1 left over, and 1 of them is 30 minutes. But you could do a whole big calculation. It is 3 minutes, but in this case I just thought, well, you know what, I can actually work it out by counting it up like that. It saves me having to do lots of calculations. Let's have a look at question 8. And question 8 is about a travel company. It says they're taking some passengers on a trip. They can either use coaches or minibuses. If they use coaches, it will take 53 passengers in each coach. And if they use minibuses, they can take 12 passengers in each minibus. The passengers going in the trip would exactly fill 3 coaches, but the company uses only minibuses. How many of the minibuses will they need? 4 marks. So what we need to find out is, first of all, how many passengers there were in total. And this is the key here. They're telling us that it exactly fills 3 coaches. So in other words, we have 53 times 3 to find out how many passengers we have. 3 times 3 is 9, nothing to carry. 3 times 5 is 15. So there are 159 passengers in total. Now those passengers we're going to split into the minibuses. Now each minibus carries 12. So you could go counting 12, 24, 36 and go counting up until you get to 159. But I'm going to do division. I'm going to say here we have 159 and I'm going to divide it into 12s. Now on the face of it, it might look a little bit horrible, but you notice that basically 12 doesn't fit into 1. But if you take these 2 here, 15, you can find that 1 lot of 12 fits into 15. Only fits in once. What's left over? Well, 12, 13, 14, 15. We have 3 left over. Okay, so now I'm looking at how many 12s fit into 39. Well, if you don't remember your 12 times table, you could just go, okay, 1 lot of 12, 2 lots of 12 is 24, 3 lots of 12 is 36, and that's looking good, because if I go more, it will be 48, and we don't have 48, we just have 39. So in other words, I have 1, 2, 3, 3 lots of 12, and we have a remainder. The remainder is from 36 to 39, 36, 37, 38. So we're basically going to have 3 left over. Okay, so in other words, we need 13 coaches and a bit extra. Now I don't need to know how much extra, we just need to know how many of these little minibuses do we need. And the minibuses we need to be able to fit them all. And if I take 13, it wouldn't be enough because there's a little bit of a remainder here that I need to work with. So in other words, I know I need more than 13 coaches. So down here, I can just say, sorry, not coaches, minibuses, 14 minibuses. Okay. Now, if you did want to do the calculation, you can, but you're wasting a little bit of time. If you do that, you can just see you need more than 13. Now, on question 9, we have one side of a triangle is extended, as you can see here. Circle the sides of the angle X. We're looking for that bit there. Now you'll recall that inside a triangle everything adds up to 180. So in other words, we can find out that one by saying 40 plus 60 is 100. And I can say, but inside a triangle is 180. 180 minus 100 means that we're left with 80. Now that's not the answer. 80 is this bit inside the triangle. But now we have a straight line, and on a straight line things also add up to 180. So if that's 180 minus 80, it means that this one over here is 100, because 100 plus 80 is 180. So you can see that the answer for that one, oh, I've made a mistake, haven't I? No, I haven't, I've just checked. 60 plus 40 is 100, 180 minus 100 is 80, that's 80, and then the other. So the answer for that one is 100. I confused myself a little while, but it's just always worthwhile checking. Next bit. Pavel uses his calculator to work this out. It's quite a big calculation. Circle the last digit of the answer. Now you don't have to do the full calculation. You just need to work out what would be the last digit when he did his calculation. And that will come from multiplying the 2 with the 8. And 2 times 8 is 16. So the last digit would be a 6. Okay. Now obviously you can't use your calculator, but that's what would come out if you did use your calculator. Okay, so 2 times 8 is 16. Last digit would be a 6. Now we have a shape. It says we have this triangle. We're going to have a rotational symmetry for order 4. In other words, you can rotate this 4 times and it would match itself. So we need to complete this diagram so that's the case. And it's going to rotate about A. Now to do that, what we'll find out is that we'll need 4 more of these triangles so that when it rotates it looks like that, and then when it rotates it looks like that. Now if you have a piece of tracing paper, you can use a piece of tracing paper, but in this case I will just fill it in by trying to make it look what it would look like when it turned round. So if we take this and it turns round, it used to go 3 up, it will now go 3 to the right. It used to go 2 along there, so it'll come down 2. So that would be part. Now obviously using a ruler would be even better, but I haven't got one with me at the moment. It used to go 3 up, so now it can also go 3 down. It used to go right, so now it will go left. And so that there will give me the other side there for this shape. And then we're missing one more. So we have here going right, so we're going to go left. It used to go down, so we're going to go up. And basically you end up with something that looks like a windmill or a fan coming out. Yeah. And what happens there is if you hold that there and you rotate it, it basically looks like itself 4 times as you go around. Okay. So that's what they meant by getting rotational order 4 coming out. 2 marks. Now we have a percentage question. It says 10% of this 2,100 is 210. So they've done that calculation for us, and it says work out what 43% is. So basically we can use the answer they've given us, because we know that 10% of the number is 210. So another 10% would be another 210. Another 10% would be 210. And I keep going until I get to 40. 10 plus 10 plus 10 plus 10 is 40, so I'm looking good. And then I need to find 43. I've got here 40, I need 3, so I'm going to need a 1%, I need another 1%, and I need another 1%, because when I add this together, I shall get 43%. Okay. Now, if this is 10%, 1% we can divide by 10 to get there, so it'd be 21. So this one here will be a 21, a 21, and a 21. So that's what we're going to add together. So when I added these, I got 43. When I add these together, I'll get what is 43 worth. So here I'll have zeros, 1, 2, 3. So I end up with a 3 there. 1, 2, 3, 4, 4, and here I have 6, so that's going to be a 10, carry 1. 2, 4, 6, 8, plus 1, 903. Okay. So it's at 903 is the answer. Let's just write it down there. 903. Now in this case, they were just testing that you understood that they've already given you part of the job and you can just complete it. Now you could also have said 4 times 10 to get that answer there. And you could have said 3 times the 1s to get that together. But I broke it down and did it in lots of little steps just to minimize the chances of making a mistake. Question 13. Kate records these numbers of cars using the drive-through each hour for 24 hours. So these are numbers of cars going through the drive-through. Kate makes this tally and frequency chart to put the data into groups. Make 2 criticisms of the tally chart and the frequency chart that Katie did. We don't need to complete it, but you could if you wanted to find the mistakes. And what happens is, as you go along, if you say, oh, okay, well, I've got a 36, and you start putting a 36 and go in there, tally, and obviously another one, 20. And then you find that actually, where do I put that 20? It could go in here, or it could go in there. So are you putting it in here or into there? So that's one of the first mistakes, is that it's not clear where you put it, because one person might put it there, another one there, and then the tally chart's not going to match. So at the moment, that's one of the mistakes that Katie's done, is she has repeated the 10s, the 20s, the 30s and the 40s in the column for number of cars. So it's ambiguous, and if you're not sure, you could always put a little arrow and kind of point that there's two of them there, yeah. And so that just so that you think, well, look, that's what I mean by it. It's repeated. There's 2 of them. Where do I put it? And then the other mistake is if you continue trying to put them in, so 37 you can put in here and stuff like that, you'll notice that you'll come across things like a 57. You'll come across a 53. Where do you put that? Because it only goes up to 50. So basically, she needed another row. Okay, so she's missing a row for 53 and 57. Basically, well, she needed another row in here. So those are the 2 mistakes. One is she's gone and repeated the 10s, the 20s, the 30s, so people don't know where to put the tallies. And the second one is she has nowhere to put the 53 and 57. But don't waste time filling all this in. Only fill it in as much to find what the mistakes are. Question 14 is a probability one, and this is actually quite nice because what they're testing is that you know the total probability adds to 1. What do I mean by that? Well, in a bag they have red, white and blue counters, and the probability of picking them, red is this, white is that, blue we don't know, but if we added all these together, the answer would come out to 1. So we can find the missing one, because it says find what the blue one is, by saying basically 1 minus this will give us the answer. So here we have 0.4. 0.4 plus 0.15 gives us a 5. 4 plus 1 is 5. So this side is 0.55. And so to add up to 1, you could see that we need a 45 in here, or you could always do it if you're not too sure. You could do subtraction, and we're doing a subtraction. Now obviously for that I'm going to have to borrow. So I'm going to have to borrow that one there, so that becomes a 0, that becomes a 10. I'm going to have to borrow from here again, so that's going to become 9, that's 10. 10 take away 5 is 5, 9 take away 5 is 4, dot, 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 0. So this answer here is 0.45, okay? But some people can do that in their head. Well done. Now question 15 is a full page question, and basically what they're asking us to do here is they provide a calculation that we will then use to answer the separate parts. So 31 times 84 is equal to 2,604. So if we're trying to work out 2,604 divided by 84, we're basically going backwards. That divided by that one will equal that one. So in this case I can just write down the answer would be 31. Okay, because going backwards is the inverse. Now the next question is saying 3.1 times 8.4. Now notice that's nearly the same. The only difference is there's a decimal between the 3 and the 1 and between the 8 and the 4. So the digits are going to be exactly the same. So I'm going to write my digits in there. 2604. But the difference is we've got one decimal place here and we've got one decimal place there. So in this multiplication we're going to have 1, 2. And there we are. See? Because there were two decimal places here. So in this answer we're going to be 1, 2 to get there. Now the last one says 31 times 85. This one's 31 times 84. So in other words, we have 84 lots of 31 to get this answer. And here we have 85 lots of 31. So to do this one, you could work it out the long way, but I could also say, you know, if there's 31 lots of 84, I'm going to end up with that number there, 2604. But I have another 31 because this has 84 of them and I have 85 of them. So I need another 31, so I'm going to add on an extra 31. 4 plus 1 is 5, 0 plus 3 is 3, 6, 2. So the answer for that would be 2,635 as a quick way of doing it, because we know that there's 84 lots of 31 in there, and I just need another one to get 85 of them. You could do a big multiplication, you'll get the same answer, you'll get all the marks as long as you get the right answer down here. Okay, so that's just two different ways of doing it. I did it the short way using what they gave us. Now we have question 16, which looks like it's a ratio one because I can see here there's the ratio dots, and they tell us that password has 30 characters. 30 characters mean symbols or letters or numbers, okay? And it says it's made up of 5 numbers, 15 letters, and the rest of them are symbols. Work out this ratio. So numbers is first, and numbers was 5. Then we had letters, there were 15 letters. And then we have symbols, and the symbols are what's left over. So 15 plus 5 is 20. 30 take away 20, it'd give us 10 there. 10 plus 10, 20 plus another 10, 30. Good. So that's how many numbers, letters and symbols we have. Now that's good, that would get you a mark, but they want it in its simplest form. So we need to now simplify it. And you'll notice they're all in the 5 times table. So this one is 1 times 5. This one is 3 times 5. And this one is 2 times 5. So in the simplest form, that's a 1, that's a 3, and that's a 2. Okay? We divided all of them by 5. The next one is a fraction question. It's asking us to give our answer as a mixed number at the end. At the moment they're not in mixed numbers, so that's something we need to remember. And when we do this, you need to have a common denominator. Now quite often people will multiply 12 times 6 to get a common denominator, which is fine, but I spot that 6 is a multiple of 12. If I double 6, I get 12. So in my case, to make my life a little bit easier, I'm just going to take that fraction and I'm going to double it. And if I double it, what I mean by doubling it, I'm going to double the numerator and the denominator. So if I double the numerator, I get 10. And if I double the denominator, I get 12. So it's still an equivalent fraction. It's still worth the same, but it looks now similar to having a similar denominator. And the other one I'm going to leave the same. You can't always do that, but here they've been very nice to us and they've made sure that we could just double that 6 to get a 12, so double the 5 to get 10. Now because they're common denominator, I can leave that as a 12 on the bottom, and 10 plus 7 is 17. That would get you 2 marks, but we haven't done it, we haven't changed it to a mixed number. Remember, when you have a mixed number, you need to keep that bit the same, that's fine, but you say, how many 12s fit into 17? And you'll notice that you can fit 1 in. And what's left over? Well, 12, 13, 14, 15, 16, 17, 5 left over. So that's what we're going to write as our answer. 1 and 5 twelfths. Okay, that's our mixed number that they wanted. Excellent. Let's move on. Question 18. Oh, nice, it's a graph. Let's have a look at this one. And it says the cost of making a phone call is a fixed charge. So whatever happens, they're going to charge you 20 pence. And then after that, for every minute, they charge you a bit extra. The cost of making a phone call up to 5 minutes are represented on the graph, and you can see that's true. 1 minute, 2, 3, 4, 5, 6 goes up to 5. Write down the fixed charge. Now fixed charge is what happens regardless. Okay, so everybody has to pay this bit, and then it's a bit extra for how long your phone call. So the fixed charge is the 20 pence, basically that bit there. Okay, so 20 pence. Now for the next bit, we're going to still have to look at this graph. So I'm just going to do it like this. Now you will have six in an exam, you'd have them side by side, but because of the camera, I'm going to do it like this so we can see what's happening. Okay, still not very clear, but never mind. Work out the charge per minute. Now charge per minute is how much extra every time you go this way, how much extra they're charging you. Okay, so every time you go this way, how much extra they charge you for 1 minute. So we need to find out what each of these little boxes is. So we have 1, 2, 3, 4, 5 boxes worth 10. So 10 divided by 5 means 2. Each little box is worth 2p. So here for 1 extra minute, because it's gone here from 0 to 1, they've charged us 2, 4, 6, 8 pence. So that's how much they're charging us. Okay. Or another way to do it is you could have said, well, from here, from 20 up to 60, there's a change of 40. Can you see that in this bit here, it went up 40? Yeah, 60 minus 20 is 40. 40 split into 5, or 40 divided by 5 is 8. You get the same answer. So there's different ways of doing it. But in this case, I just found out what was each of these little boxes worth. And when it went 1 minute this way, I said, it's gone up another 8 pence. So now it says work out the cost of phone call lasting 7 minutes. So whatever happens, they're going to have to do 20 pence for the fixed bit. Yeah, that's whatever happens, plus 7 lots of 8. Okay, so for every minute, they have to pay 8 pence. So what we have here is a BODMASing, so we're going to have to work that bit out there. And 8 times 7 will give us 56p. Plus the 20p that is a fixed cost, so 20 plus 50, 70, so it will come out to 76 pence as a charge for this one. Okay, basically for every minute you have to pay 8p, but there's a fixed charge of 20 whatever happens. Now question 19, what's question 19 looking at like? Let me just put those papers in order. Okay, so question 19 has some information about bags of toffees and bags of mints. And they tell us here, these are the sweets in each of 11 bags. And as you can see, they change. Some of them have a little less and some of them have more in them. Okay, and again for the bags of mints. The company claims that the average number of sweets per bag is at least 50. Using medians, now be careful, let's see, medians, is the company claim correct for each one? So don't go doing mean or mode, they want medians. So we need to put them in order and then find. Now in this case, you'll notice they are already in order, so it's looking good, but here they're not in order. So we're going to have to put them in order before we do anything. So let's see, what's the lowest one there? There's a 49, there's a 47. So we're going to take that 47. We have 47. The next lowest one is going to be that 49. So I'm just putting them in order. And then after that, there's a 50 here. But you'll notice there's another 50. After 50, there's a 51. Let's cross that one off. 51. After 51, and there is a 54. Oh, I missed out a 49. There were two 49s. Sorry about that. Let me squish that 49 in there. There we are. That's the good thing about crossing them off. You can then see if you missed crossing one off. There's a 55 there. There's another 55. Now most people are really, and as you notice, I left out a 54, so let me put that 54 in there. There's a 55 there, and there's 57. Now let me see, there are 11 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 things. Now the good thing about crossing them off is you can then spot, like I did, that I've actually missed out a 49 and I missed out a 54. Otherwise you could get them in the wrong place, or you might miss one out. And you notice that I counted at the end to make sure I still had 11 things. Okay. Now the median is the middle one once they're in order, so we need to find now the middle one. So I'm going to go 1 on each side, 2 on each side, 3 on each side, 4 on each side, 5 on each side, and you notice that we end up with 51 as the median. So here it says, using medians, are they correct? And then they said at least 50, so that means 50 or more. In this case, 51 is more than 50, so I would say yes for the toffees. Okay. But when we come down to the mints, let's have a look. Now the mints are already in order, so I could actually use this one. 1, 2, 3, 4. Ooh, 4 on each side, so we now need to find the middle number between those two. Now this is quite nice. You can see that 49 would be bang in the middle, yes? 48, 49, 50. So in this case, the median comes out to 49, so the answer is no. Okay. Now they can see what I've done. I've circled it here, and they can see I've done it there. But if you want to cover your back, you could always just write median equals 51, and here median equals 49, and then there's no doubt that you knew what you were doing, and they can't kind of quiz it, even though I did show it elsewhere, because it's a 4-mark question, and it's a nice easy one really, so I don't want them not giving me the marks for that. Then we come to question number 20. Freddie tries to work this out. His answer is 37.65. By rounding each number to the nearest 10, show that his answer is incorrect. So in other words, it doesn't look like 37.65 or something close to that. Okay. So the first number, if we round it, 29 would look very similar to 30 if we round it to the nearest 10. And 83, the nearest 10 would be 80. And here for the denominator, the nearest one would be 10. Now 80 plus 30 would be 110. 80, 90, 100, yeah, just checking. And then we're dividing by 10. Now dividing by 10, we can cross off those zeros, so we end up with 11. And you notice that 11 is nothing close to 37. If we round that to the nearest 10, that would be 40. 37 or 40 is nowhere near 11. So you can see that he is incorrect, okay? So 11 would be our answer. Just be careful when rounding. Sometimes we round up, sometimes we round down, depending on what's the nearest number. In this case, we're looking for the nearest 10. Ooh, we're on to shapes now. It says a straight line passes through two parallel lines. Those are my parallel lines. And it says circle the angle that is corresponding to x. Now, corresponding means it matches it. So if you notice when we do that, x is the top right-hand quadrant. So when we're here, the one that matches it would be B. So in this case, we want to say B is the corresponding one. Okay. Opposites would be these two. Okay, or opposites would be those two, alternate opposites. And if we're looking for alternate angles, again, it depends how they were doing. But in this case, corresponding just means it matches, and that top right-hand quadrant would match this top right-hand quadrant there. So it's a B. Lucy wants to simplify this algebra expression, and she writes it as 4a minus 7b. Is she correct? So we need to do the workings ourselves to see what happens. Now remember, BODMAS, we do everything in the bracket first, okay? But we can't do much because there's a B and an A, and they are different things, so it's not like I can do anything there. So in other words, we're just going to say, okay, well, there's nothing I can do in the bracket. So what I'm just going to say here is that we had a 6a. We're taking away a 7b, yeah, because we're taking away everything in the bracket, but we're also taking away a negative, so we're taking away a negative 2a. Okay. Now notice I was very careful to say I'm taking away everything in the bracket, so you're taking away a positive 7b, but I'm taking away a negative 2a. And when I take away a negative, that's the same as adding. So if that helps you, just remind that that's more like an adding there, yeah. So in other words, we have 7a plus 2a, sorry, 6a plus 2a would be 8a. So this here would be equal to 8a. And the 7b, there's nothing we can do with it, so that stays as a minus 7b. Does it look like what she did? No, it doesn't. So, and so here I could say my reason, it should be 8a minus 7b. So my reason is I actually give them the answer. Okay. But you could also say, well, she actually forgot to take away, because what she did is she said 6 take away 2, which is not true. It's 6 take away a negative 2, and that's what happened there. Okay, so be very careful about taking away a negative. You come down to this bottom part, and it says Lucy also wants to simplify this 3p squared times 5p to the power of 7, and she says add the 3 and the 5, and then add the 2 and the 7. And here is her answer. Now, you all know multiplying doesn't really work like that. Here what we have is 3 times 5, but you do add the powers, because what we have here is p times p p times p times p times p, basically 7 lots of them. And so when we do that, we have 7 lots of p's here and 2 there. So you could and definitely do this bit. So this bit here is okay, but this bit here we know is not right. 3 times 5 is going to be 15. So that bit there is wrong. Okay, so add the 3 and the 5. That is not correct. It should be 3 times 5. But add the 2 and the 7. That bit is correct. And so they're trying to fool you or confuse you by doing that. Okay. Lucy thinks, oh, we're still with Lucy. Lucy thinks that 10 times a number is the same as 10 divided by number. Give a possible value for the number. Now, she's not saying this is always true, okay? She's basically saying that it can be possible because she thinks of a number that is possible, okay? Now, you're timesing by something and dividing by it. Now, really, the only thing that works there is 1, okay? What do I mean by that? Well, 10 times 1 gives you 10, and 10 divided by 1 also gives you 10, okay? And those two are then the same. So 1 is like the magic number here because it doesn't really make any difference to it. So it's possible. So that would be our answer, 1. Lily's age is 2 years and 4 months. Hugo's age is 1 year and 8 months. Write Lily's age in months as a fraction of Hugo's age in months. So in other words, we have to change it all to months. Okay, before we can do anything with fractions, we need to write it as months. So here, if we do Lily, in a year there are 12 months. So she's got 2 lots of 12. 2 lots of 12 would be 24, plus the 4 that she had. So Lily is 28 months. Okay. Hugo is 1 year, so that's going to just be 12 months there. So he, when we do his, is going to be 1 lots of 12 plus 8. So he is going to be 20 months. Okay, 2 lots of 12 is 24 plus 4, and 1 lots of 12 plus 8. Now we know what Lily and Hugo's ages are in months, so we're okay for this bit. And it says write the Lily's age as a fraction of Hugo. So notice Lily's age as a fraction, so Lily will be first. Okay, Lily is 28, so we're going to write 28. Okay, as a fraction of Hugo's age. So Hugo's age is 20. Now don't worry, it's top heavy. You're allowed to have top heavy fractions if you wanted. If they'd said write Hugo's age then as a fraction of Lily's, then it would be the other way around. But here they said Lily's age, so Lily's on top. Now we've got it as a fraction, so don't change it to mixed. Okay, don't say, oh, there's 20, there's one, but it does say simplified. And you'll notice that they're both in the 2 times tables. How do I know that? That ends in a 0, so like 2 times 10, and this ends in an 8. 8 is an even number, so basically we can halve them. So half of 28 is 14, half of 20 is 10, and you notice we can do it again. So half of 14 is 7, half of 10 is 5, so the answer for this one as a fraction will be 7 over 5. Okay, you can write it like that, or you can write it like this. Doesn't really matter, it's your choice, okay? But 7 over 5 is what they're looking for. If you leave it like this or like that, you get 1 mark. Working alone, it takes Kevin 4 hours to paint an area of 12 meters squared. Kevin and Steve are going to paint an area of 24. Kevin says working together at the same rate will take us 8 hours because 2 lots of 12 is 24. So he's just saying, oh, it takes Kevin 4 hours to paint that. So they got twice the area, so it takes them twice as long as what he says. But you have to remember, there's 2 people now. Okay, so whilst there's more area to paint, if Kevin was doing it on his own, this is correct, because Kevin would have to do twice the amount of area, so it would take him twice as long. But there's actually 2 people now to do the job. So is he correct? And I say no. And I say because there are twice or twice as many people to do the job. Okay, so in other words, 24 divided, each of them could do that. So one of them would take them 4 hours to do that, the other one would take them 4 hours, so it would take them 4 hours to do the job. So I'm just going to put in there. just so they can know that it will take them 4 hours. Okay, but the thing is, yes, it's twice the area, but there's 2 people doing the job, so they can split the job between them and get it done faster. We have here an inequality, and it's asking us to solve it. Now, solving it means that at the very end, we will need to work out with x being inequality and a number. Okay. Now, the way I do these is I basically don't worry about the inequality. I think of it as an equals. So I'm just going to write here 5x plus 6 equals 3x plus 15. And then I just collect all my x's on one side and I collect all my numbers on one side. And to do that, what I basically need to do is I say, okay, I don't want this one here, so I'm going to take away that 6 from there, which means I'm going to take away 6 from there. So when I do that, 6 take away 6 will disappear from this side, and I'll just be left with a 5x equals a 3x on here. 15 take away 6 will leave me with a plus 9. Yeah, 15 take away 6, or 9 plus 6 is 15. Now I want to collect my x's. Now you could have done this first. I just chose to do the numbers first, but you could have done the x first. I'm going to take the 3x from this side. So I'm going to take 3x away from this side. Okay. Now you could have done this before. You could have done it like I did later. It doesn't matter. 3x take away 3x disappears, and on this side I'm just going to get a 9. And 5 take away 3 will leave me with 2x. So if you did this first, you would still get 2x is equal to 9. Then what we need to do is we need to get the x on its own, so we divide by 2 on this side. So we're going to divide by 2 on that side because opposite multipliers divide. And in that case, this cancels here to just leave me with an x. And here, 9 divided by 2 is 4.5, but you could leave it as 9 over 2. It doesn't matter. Okay. But at this point, I remind myself, I did not have an equal sign to start with. What did I have at the start? I had that sign there. So I just copy it back in. And so I can just copy it back in here. I can put 4.5, or as I said, if you prefer, you could have written it this way, 9 over 2. Absolutely fine. That's just as good as that one. You have a choice, okay? But that's what they want. So remember what we did. We made that into an equals. We collected the numbers and the x's. I collected all the x's on one side and all the numbers on the other side to solve it like you would do normally any equation. And at the very end, I just put the symbol back in and gave my answer, okay? Putting a bracket around that because it's only one of those you need. You don't need both. And then here it says these are quite nice. Write down the inequality represented by this number line. Now remember, this number line are all the values that are allowed on this line. Now I'm going to call those x. So this line here is x. So I'm going to write x here. Okay. And where did it start? It started at 2. Where did it finish? It finished at 5. X was between 2 and 5. That's what I've written. X is between 2 and 5. Now comes a bit that you just have to remember. If it's coloured in, it means it can also be equal. So I'm going to have an equal. So X was bigger or equal to 2. But this one is not coloured in, so that one I won't put the equal sign in. So X is less than 5. And that's the answer. So notice I just had the X between 2 and 5. If it's filled in, you can have the equal sign in there. If it's not filled in, you don't put the equal sign in there. You're doing really well. We're nearly there. This is 26, and how many questions are there? There's 28. Oh, we're nearly there. There's 32 questions, so that's fine. You're more than a quarter of the way through, okay? Now here we have a shape, and they've told us that this shape is an octagon, and you can see it has 8 sides. And they told us it has 2 lines of symmetry. One is where x equals 1, so that dashed line there means that this side is the same as that side. And this dashed line there tells us that this bottom bit is the same as that bottom bit there. Okay, so it's just mirror imaged over. And they're asking us to find the coordinates of Q. Now for this one, you have to be a little bit careful of how you think about things, okay? So we'll use the information they've given us. They've given us this point here. Now this point here, this grey line are the x and the y axis. So when it says -2 here, this bit here is at 0, and basically it's telling us that this one there is at -2, yeah? But the line of symmetry is from here. So in other words, we're -2 and another 1, because it says 1 here. So the actual distance here, that distance there, is 3, yeah? So it's a jump of -2 to get to 0, and then another jump here to get to the 1. So that's a jump of 3. Now if it's symmetric, it means that this distance on that side is also 3, yeah, because it has to be equally on both sides to be symmetric. Now that means that point Q is 3 away from the dotted line, but we don't use that. We will use our X on our Y axis. So if I were to say to you, how far along from this axis is it? You say, well, there's 3 and another one here, so we're actually 4 along. So that there is 4 in this direction, okay? Because it was 3, so 3 here. But if I'm measuring it from this grey axis, it is 1 and another 3, so that's 4. So that's where I get that 4 from. So the coordinate for the x-axis for this one comes out to 4. Okay. A little think about it and you think, where did it come from? Now the other one. This here is symmetric. The distance from there to there is the same as the distance from there to there. Okay. But how far down was it from the x-axis? It's -6 down. So this bit here from the x-axis is going down 6. Okay, so this bit here is going down 6. But to get to the symmetry line, it's going up another 5. This distance there, because they tell us it's 5. So the full distance, this full distance here is 6 and 5, 11. So that's how long that bit there is. So in other words, going up, sorry, I made it drawing, so it's meant to go all the way down here to get to that one there. Going all that one there. So this 6 and that's 5 is 11, which means to get to this point up here is going to be a jump of 11. However, it's 11 from the axis, but we want to have from this axis. So we need 11 and another 5, which would be 11 and 5, 16. So the one for that one there would be 16. This is a tricky question. And what I would recommend in an exam is if you're not into these type of questions, leave it till the end. If you have time, come back to it. If you don't have time, you've not wasted loads of time. Because it's very easy to get really confused by all the different values on there, okay? But it is doable if you have time left over at the end to come and do it. But I wouldn't waste time on it, really. Okay, now we're on to standard form. And it says work this out and then write it standard form. So the first thing we're going to do is going to work it out. We know that 2 times 7 is 14. And then we count number zeros. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. So I just multiplied the 2 and the 7 to get 14. And then basically I copied all the zeros down. Now that there is okay. We've worked out the calculation, but they want it in standard form. How does standard form look like? Well, the standard form has a whole integer number and then a decimal place, and they might have some numbers afterwards. They don't always. And then afterwards it will have something like times 10, and it will have a power. If the power is here a negative, the number is less than 1, but this time it's bigger than 1, so it's going to be a positive power there. So when we do this one, what we're going to do is we're going to basically end up putting a dot here, okay? But the dot has had to move 1, 2, 3, 4, 5, 6, 7, 8 spots to get to that position there. Okay, so the power will be 8. And what do we end up here? We end up with a 1.4. I don't put any of the zeros there because they're redundant. You don't need that. So when I write my answer, I'll write 1.4 times 10 to the power of 8. And it's a positive one because it's a number that was bigger than 0. Bigger than 1, I meant. If it's something like 0.000, then it would have been a negative. Okay. We come to another standard form and it says work this one out. Now there's 2 ways of doing this. You can change it to an ordinary number first and then do the calculation, or you could use some of the knowledge we have about powers and indices to work it out. I'll do it both ways, but you need to choose which one suits you. Okay. Now the first one is I'm just going to change it back to ordinary numbers. To do that, I have here 1.8, but basically it's to the power of 2, so we go 1, 2. So on the top I have 180. And on the bottom I have a 3, but notice it says negative, so it meant that the dot actually moves in this direction there. Okay, 1. So if I'm using ordinary numbers, that's the calculation we're doing. We're doing 180 divided by 0.3. Now I don't like dividing by decimals, so what I'm going to do is I'm going to times the top by 10 and the bottom by 10, because if you do something to top and the bottom in fractions, it doesn't change it, but it makes the calculation easier. If I multiply that one by 10, I'll end up with 1,800. And if I multiply this one by 10, I end up with 3. Now that's easier to do because we could say how many 3's in 18? 6, because 6 times 3 is 18, and then put 2 zeros, and so that's your answer, 600. It says ordinary number, there you are. So the answer down here is 600. Okay. If you wanted to do it using standard form, what you could say is how many 3's fit into 1.8, and what we would do there is we'd do the similar idea. We could say times that one by 10 to get 18, and this one here, no, that's fine, we would do it like that. 1.8 divided by 3, so 1.8 divided by 3. If we did that, we'd end up with a 6, but because there's a decimal point there, you'd put a decimal in here, okay? And then here, when you divide, you subtract. 2 minus 1 would give us 3, so that'd be times 10 to the 3. And if we did that, we'd put a 6 times 10 to the 3. Basically, we would go going, there's a dot, there was a dot here, 1, 2, 3, and we'll end up with 600, just like we did before. But I actually think that one's a bit easier than this one in this case. But it's your choice, whatever suits you. Everybody has slightly different ways of doing things, but the answer is 600. Now here's a problem-solving type question. And to start with, it looks rather horrid, but it's not as bad as it first sounds, okay? So let's look what we have. We have a motorway, A, B, C, and D, along the motorway. They tell us between C and D is 3 times A and B. So whatever this is, there are 3 of them there. They tell us that the distance between B and C is 25. So I'm just going to write that down now, okay? Just so I don't forget. The distance between there and there is 25 miles. Okay, just so I know. Salma drives between A and C. So she drives that, and she drives it in 30 minutes at an average speed of 62 miles per hour. Okay, so think of this. In 1 hour, she travels 62 miles. But 30 minutes, half an hour. So she travels for half the time. If she travels for half the time, she'll travel and covers half the distance. So in other words, from this information here, I know she has travelled 31 miles. Okay, 30 minutes is half the time. In 1 full hour, she does 62. So half of 62, 31. So I know that between here, A, and C, it is 31. But I also know that between B and C is 25, so I can work out that this bit here is 31 minus 25, 6. Yeah, 31 minus 25, 6. And we also know that whatever happens between A and B, 3 of them is C and D. So this bit here will be 3 lots of 6, which would be 18. So the total distance between A and D will be 6 plus 25 plus 18, or 31 plus 18. So I'm going to do 31 plus 18. 8 plus 1 is 9. 3 plus 1 is 4. The total distance is 49 miles. Okay, or as we said, if you added those together, you get 31, 31, and 10, 41. 41 plus 9, plus 8 is 49. Okay, so that question looked horrible, but because I've given only half an hour was nice because it's just half of this, sorry, half that, and it works out really, really nicely, that question. Now question 29 is a graph they've drawn, and it's asking which of these equations match it. Now, if you're not sure about this, you just try a couple of values, okay? So imagine you tried something easy, something like a 1, and something over here like a 10, okay? If I do this one, that is basically saying a constant, I don't know what constant it is, but imagine some constant k, times 1 will just give me k coming out, so y equals k. So, and then if I did that again, k times 10, I'd get 10k. So notice, for this question here, it would have gone from k to 10 lots of k. So in this case, the graph would be growing. It'd be doing something like this. It starts off small at 1, starts off a k, and then by the time here it's 10, it's gone up to 10 lots of k, so it's grown. Okay. This is a straight line equation. How do I know that? Because to a power of 1, and anything like that is growing. positive. So if you know your gradients and stuff, that comes out to something where basically it's just joining, doing something like that. Okay, but again, if you put some values in there, 1 plus k, so when it's 1 you get a value of k coming out. Then if you put something like 10 in here, 10 plus k would just give you something higher, so it's growing. And on this one here, it's a negative gradient, so basically it's coming down. So what happens is it's basically this answer here. You think, well, how do I know? Well, it's an inverse proportion graph, and inverse proportions, the bigger the x gets, because you're dividing by a bigger number, the smaller the answer. So if I divide by 1, I get quite an okay answer. If I divide by 10, I'm going to get a smaller answer, and sure enough, I get a smaller answer coming out. So this is an inverse proportion graph, okay? And you kind of recognize them with some practice. Question 30 is a product of prime factors, and they ask us to give it in index form. This is really nice. This is basically where you split numbers up into their prime factors, and you choose what you want, okay? Whatever suits you. I am going to go for, oh, what's the nice one for this one? You could do 2 times 100. You could do 20 times 10. I'm going to go for 20 times 10, but you could have done other ones if you want to do. Okay. 20 splits into a 4 times a 5. Now a 5 is a prime number, so I can stop there, but a 4 isn't, so I can split a 4 into a 2 times a 2. 2 is a prime number, so I stop there. So 2 times 2 is a 4, and the 5 was already there. 4 times 5 is 20. We split this one up, same. 10 can be split into a 2 and a 5, and you notice 2 is prime and 5 is prime. So in this case, those are our prime factors. Now I could write 2 times 2 times 2 times 5 times 5, but they want it in index form. So when I come over here, 200 can be written as 2, 1, 2, 3 to the power 3, times 5, because there are 2 5s, to the power 2. And that's what I mean by index form. 2 to the power 3, or 2 cubed, times 5 squared, or 5 to the power 2. That's nice. Okay, we are now on to the last 2 questions. It's a trigonometry one and a factorizing one. And these are normally quite tricky because they're right at the end. Now, trigonometry are to do with your SOHCAHTOA. Okay, and you have a right angle triangle and you label what you have. If that's my angle, this is my opposite, because opposite the angle. The long one is your hypotenuse, and the other one is your your adjacent. Okay. So in this question, we are looking for x, which is O, and we have h, which is 10. So we don't have anything to do with a. We're not looking for it, and we don't have it. So when I do SOHCAHTOA, I need the one that doesn't have the a. And notice here there's an a, so I don't want that one. Notice here there's an a, so I don't want that one. So the one I want is sine. So I'm going to write that down. Sine of the angle 30 is equal to opposite. Opposite was x, divided by hypotenuse, which is 10. Okay, so that is a ratio. Sine 30 is equal to x over 10. Now, if this was a calculator one, we could just use our calculator, but it's a non-calculator paper, so we're looking to know, or they're testing to know, that you know the exact values for trig. And this is pretty tricky, so you should have kind of memorized them, but if you haven't memorized them, the way it works is that we can have our triangle. I'm going to just have here a triangle, and it's an equilateral triangle, so this angle here is 60, but this one here I'm going to split. If it's 60, you'll end up with a 30 there and a 30 there. Okay, and obviously that side there is 60. Now the sides of this triangle, I'm going to, because they're equilateral, I'm going to call that one a 2, and that one there will be a 2 because they're equilateral. But because of the way I've drawn it, I'm going to split this into 2 and 2, into a 1 there and a 1 there. Okay. And the reason we do that is I'm trying to also find out what this one is here. Okay. Now notice, in this question, I don't need the adjacent, so I'm not going to really worry about that. Okay. What do we have? When I do this one, if I use this triangle here, sorry about that, triangle there, I end up with sine of 30 is equal to opposite over hypotenuse. So sine of 30 is equal to a half. So sine of 30 is equal to this, but also sine of 30 is equal to half. So if you have that, we can make our fractions equivalent. So this one is 1 over x over 10 is the same as a half. Okay, so now we just need to work out what's happened. And you notice to go here, 2 lots of 5, 2 times 5 is 10, so we do the same to the top, 1 times 5. So this answer here, x is 5 centimeters, yeah? Because 5 over 10 is the same as 1 over 2. But that's knowing the exact values for your trig functions, which kind of takes a little bit of memory and practice with. And we're on to the last one. Now factorizing means you're going to put brackets in. Because this is squared, what's going to come out is you're going to end up with 2 brackets coming out. Okay, so the final answer down here is going to be 2 brackets. Now factorizing a quadratic is one of the more tricky ones, because basically we want 2 numbers. Now the easy bit is this one, x squared, because that's going to be an x here times an x there would give us x squared. But what we're looking for is we're looking for 2 numbers that multiply to give 10. So 2 numbers that when you times them gives you 10. So 2 numbers that when you multiply them gives 10, because that number times that number will get a 10. And we're also looking for those same numbers that when you add them will give us a 7. That's 7 there. Okay, so you're looking for 2 numbers that multiply to give 10 and 2 numbers that add to give 7. And if you think about it, to make 10 you could have a 2 times a 5, and a 2 plus a 5 also gives you 7. So our 2 magic numbers are 2 and 5. So in this case, and notice it's all positive, so I don't need to worry about that. So this one's going to be a plus 2, this one's going to be a plus 5, because when I multiply that I'll get the 10, and when I add them I'll get the 7. So the answer is x plus 2, x plus 5. Excellent! Well done for getting this far, and good luck. Bye!